Okay, we're gonna first be talking about double angles. One little double stuff Oreo question here for help picture remember. But here's our formulas for this. Sine 2u will be 2 times sine u cosine u. And actually, if you think about this here, if you remember the formula for sine u plus w, you have sine u cosine w plus sine u cosine w. One thing about it is your w's will be u's, so that's why this formula is just that. I know that on the cosine 2u here, we had the cosine u times cosine w minus the sine u times sine w. So, and you had the cosine one, I think, squared, and is it kind of being a Pythagorean? It's kind of almost a little Pythagorean right there, except for that 2. And that would be why, because 1 minus, yeah, and then here, the tangent one, we have this one right here for tangent. These are our formulas for our double angles that we'll be using, okay? And how we're going to use it is like right here. And if you would, cosine's 5/13. Now here's a big key. Y'all, cosine is x over r, okay? And the whole reason for this right here is I already drew the picture, is for me to know what quadrant it's in. Think about it. Where is 3 pi over 2 on your unit circle? It's straight down, right? Look over there, and then 2 pi is like back up here. So this is obviously in quadrant what? 4. The reason that's important, x is positive, r is always positive, but what's your y in quadrant 4?
Wait, what is R?
R is the like the radius. Like if we were to draw a circle and keep going around here, r would be the radius value, or the hypotenuse of the triangle. It's going to be the hypotenuse of the triangle. Here's our x. Remember, so we always draw our alpha angle back to the x. That way x is always the cosine, y is always the sine on the unit circle, but that's where the r is the length of 1. So if r is not a length of 1, that's going to be, in a sense, so what's going to happen is cosine is x over r. So I know this one's what, 5 over 13, and I know the 5 is positive, and r is always positive. So the question is, I'm going to use Pythagorean theorem to find the other side. Now I know it's a 5, 12, 13, but if I plug the 5 in and 13 in, square them, minus the 25, then square root the 144, you get, it can be positive 12 or negative 12, which is the whole reason I said that I need to know what quadrant it's in. Because over here I know the 12 has to be what? Down here y is what? Negative. So the y has to be a negative 12. And that's real important because you might want to write this down. I don't think it's going to pop up or not. But cosine is x over r. Sine is y over r, and tangent is y over x. So what's going to happen is this here.
No, it wasn't done.
Oh, okay. So like, and here's what's really nice with the calculator. If you're doing it with the calculator, you can just do 13 squared minus 5 squared and then like square root it to get that 12. But like I said, you have to know what quadrant it's in to determine whether it's what, positive or negative for that part right there. Okay? Now, and that's all that we did right there. Now, what we're going to do next is this. I need to come up here and to find sine 2u, I need to plug this in. But I need to have sine and cosine. I already have cosine u. Cosine u is 5/13. But I don't have what? Sine. And sine's the what? Y over r. And what did we say y was? Negative 12. So it's going to make it negative 12 over 13. So sine's negative 12 over 13. And cosine's 5 over 13. To find sine 2u, or to double the angle, all I'm going to do is plug it in, and the doggy's not going to show up today. So here's what I plug in. Now you can go straight to your calculator, type it in if you want, but I kind of did this here. I mean, 2 times 12 is negative 24. I did 2 times 5 because that's easy, it's 10. 10 times negative 12 is what? Negative what? 120. And 13 times 13 I know is 169. So it's negative 120 over 169. Okay? Negative 120 over 169. Okay? That would be the sine value. To find the cosine, here's the formula. 2 cosine squared u minus 1. Well, the cosine value was given to me as what? 5 over what? 13, right? So just go what? Plug it in, plug it in. So I'm going to take 2 times 5/13 squared minus 1. Now, y'all, here's what's nice about calculators. You can type it in and get the answer. But 5/13, if you want to do the math ways, it's 25 over 169. Multiply 2 times 25 is 50. But then here's the problem. To minus 1, I need a what? Common what? denominator. So if this is 169, that has to be 169 over 169. So 50 minus 169, I think makes negative 119 over 169. Okay, so I know this here for this angle. Sine's negative 120 over 169. Cosine is negative 119 over 169. All right, so I have found sine, basically 2 theta. I found cosine 2 theta. I just used u because that was the formula was a u. I still need to find what? The tangent of 2 theta. And we're going to go to that in a second. I can tell you I still write some stuff down, so I'll wait up a second before I move on to the tangent part. Looks like we're done with that right there. Okay, the tangent part. All right, the tangent part is this formula. But what do I have? What have I not figured out yet? I haven't found tangent. Tangent's what? Y over x. So what's y? Negative 12. And what's x? So now I'm going to go up here and plug this into my formula. Now, y'all, you can type it in the calculator if you want. I probably would do it if I do it on the top divided by the bottom, and I'll show that here in a second. But as a math teacher, I'm going to do the 2 times negative 12. I'm also going to take the negative 12 and square it. Now notice, y'all, what's negative 12 times negative 12 makes what? Positive what? 144. Well, how come this is a minus? Because I'm minusing what? This quantity. That's why that's still a minus. I need to make the 1 into a common denominator. So I have a 25 here. I'm going to make a 25 there. All right? And basically, I'm going to rewrite that with just the 25 like that. How do you divide fractions? Remember, keep the first one, flip the second, change, or like to have my little Diana Ross.
Down, upside down, upside down.
All right. Now, y'all, you can, 5 will go into 25. I'm going to cross cancel, make the math a little easier. And then 5 times negative 24 already knows like 120. And a negative divided by negative, so there's the tangent answer, 120 over 119. All right. Now, but y'all, here's what I would probably have done. I would probably have gone right here to my calculator at this stage right here. And this is the way I do it. All right. I would have turned it on. And I would do 2, this is in parentheses, negative 12 divided by 5. And I would have hit enter, because I don't like doing all this like parentheses stuff. Now just remember, first of all, what's nice about these calculators, that negative 4.8 is going to stay there for a second, right? And then I'm going to come down here, and I'm going to do 1 minus calculator, the negative 12 divided by 5, parentheses, and then hit my squared, and hit enter. And then I've got this here, and then I would just do this. I would do negative 4.8 divided by negative 4.76, and then hit math, option 1, fraction, enter, and I got the 120 over 119, which made the work really, really wide, even a little bit wide. Easier to do, because why do you have to do all those steps and stuff? We have calculators, you might as well why? Use them. All right, say that there. And while we're on that here, let me mention this here. Here's how you would type them in the calculator through math, option 1. That's just the same thing. That's the same problems, just with the what? Calculator, how you would like. And I kind of showed one of them with the calculator right there. That's how you do the double angles with those right there for you. You find double angles with the calculator.